So I uploaded a video which is some of the basic concepts of chemistry, that is mole concept 1, and I'll be discussing about some more basics which is mole concept. This is second video. This one I'm going to explain now. Mole concept, which is basics that everyone requires. Now we have learned up to Avogadro number and etc. those basics. Now we will be learning about AMU, which is atomic mass unit. Atomic mass unit. One AMU. One AMU is equal to 1/12th of mass of 12 grams mass of an atom of one atom, that is this is one atom, mass of one atom of 12 grams of carbon, which is C12. 12 grams of C12 is also known as 12 grams of carbon. So 1 AMU is 1/12th of mass of one atom of carbon 12. And also 1 AMU is equal to 1 by Avogadro number of grams, which is 1 by 6.022 into 10 to the power of 23 grams. This is actually atomic mass unit is introduced. This is a specific unit which is measured in chemistry, especially for atoms. That is, for an atom, its weight, that is atomic mass unit. So for measuring of atoms, a special unit was introduced in the chemistry, which is known as atomic mass unit. And atomic mass unit is already explained, that is 1/12th into mass of one atom of 12 grams of carbon. And relation between grams and AMU is given by 1 AMU is equal to 1 by Avogadro number of grams. Now let us discuss about molar mass. Molar mass or molecular mass. Molecular mass or molar mass is defined as the mass of, it is defined as the mass of 1 mole of a substance. It may be anything. 1 mole of a substance, mass of 1 mole of substance is defined as molar mass. For an example, let's talk about sodium. One atom of sodium contains how many AMU? 23 AMU. 1 mole of Na contains 23 grams. This is what the difference. One atom of Na contains 23 atomic mass units, and one mole of Na, that is Avogadro number of atoms. Some and in some accepted Avogadro number of atoms of Na contains 23 grams. This is called molecular mass. This is mass of 1 mole of Na. Here the substance is Na. So I think you understand. Molar mass is nothing but mass of 1 mole of a substance. This is the thing that I want to explain. And now let's talk about number of moles. There is a relation between molar mass and number of moles. Actually, number of moles is given by given mass, that is the mass given in the question, that is how much mass did they take that compound of, did they take off the compound, so by molar mass, which we have learned now. Suppose for understanding better, let's take an example. Let us take example as CO2. In CO2, how many the molar mass of CO2 is 12 plus 2 into 16, which is 32 plus 12, which is nothing but 44 grams actually. Yes, 12 plus 16 into 2, which is 12 plus 32, which is 44 actually. 44 gram per mole or gram mole inverse, either gram per mole or gram mole inverse. Now it contains, let's say, 22 grams. Let's say in the question it was given that 22 grams of carbon dioxide was took or was taken, because the past tense taken is to be used, and let's say 22 grams of CO2 was taken in the question. So they are asking us to find number of moles of CO2 of 22. So we can do it simply because we have a formula, number of moles, which is equal to given mass by molar mass. Given mass is 22 and molar mass is 44. So let's calculate number of moles. Number of moles gives us 22 by 44, which is 1.5, which is 0.5 moles. 0.5 mole. So this is the formula, and the most important thing is, let's recapture whatever we learned until now. Let's say number of unit particles, and let's say moles, number of moles, and let's say mass that was provided in the question. Let's give mass. Stay here. That would be nice. That will be different. Now, if in the question number of unit particles were given and we were asked to find number of moles, then we can divide it by Avogadro number. By dividing number of particles with Avogadro number, we will be getting number of moles. So if in the question number of moles were given, see this arrow direction. Now we should divide it by Avogadro number, then we will be getting number of moles. Suppose in the question number of moles were given and we are asked to find number of unit particles, then we will be finding by multiplying with Avogadro number. Already we know that the formula, number of moles is equal to number of unit particles by Avogadro number. So by that this relation came, and number of moles, if we were given number of moles and we were asked to find out the mass of the substance that is taken in the question, that is taken already in the question, which is, if they asked in the question how much mass did they take. Suppose they were doing some experiment and they took some of the mass, some x quantity, some mass of x quantity, x grams of some substance, and they told to find out that, and you are given number of moles. Then you should just multiply it by molar mass, molecular mass, which is the total molecular mass of 1 mole of substance. Don't forget. And if we are given number of moles, to convert it into given mass, we should multiply it by molar mass, and vice versa while coming from, sorry, this direction is this. Vice versa from coming from, if mass was given in the question and we are asked to find number of moles, then we should divide it by molar. This is the concept we learned until now. So these are the basics of mole concept. And still there are topics like mixture fraction. Mixture fraction is nothing but like it consists of topics like mole fraction, mass fraction, mole percentage fraction, mass percentage fraction, etc. These all are it contains some extra topic which I'll be explaining afterwards. Uh, this is the video of today. Second video today. So, so let's do an example and close this session as of now. Mm. I'll explain you also one more topic which is ideal gas equation, which is everybody knows. Actually, this is in the topic of states of matter, but a small amount should be learned now. That is, there are questions from this concept, especially in the names. Uh, what is ideal gas? We all know that the gas that follows the ideal gas equation is known as ideal gas. What is ideal gas equation? PV is equal to nRT. Everybody knows it. Now, PV is equal to nRT. Here, what is P? This is the pressure exerted by gas. Suppose let's take a container. Let's fill it. Now V. V is volume of not the gas. Here everybody knows. Volume of the container. That is this. Let's say this container. This container's volume. Here V refers to the volume of the container, and N refers to number of moles of gas. So everybody knows number of moles of gas, and R is universal gas constant. Universal gas constant, and you should also be remembering this one. R is equal to R is equal to 0.0821 liter atmosphere per Kelvin. Universal gas constant value is this, which is 0.0821 liter atmosphere per Kelvin mole. This is universal gas constant, and it should be remembered to solve questions. And this is temperature, we already know, which should be always taken in Kelvin because it's a unit of it is Kelvin. And let's talk about this and thing. Suppose we have a container. Here volume is constant. Suppose let's say temperature is also constant. Constant. We already know that R is always constant because it is universal gas constant. Then the pressure in the gas, the pressure of the exerted by the gas is directly proportional to number of moles present in the gas. This is a very good relation which is mostly useful in JMX. When volume and temperature of the gas molecules present in the container are kept at constant, then pressure exerted by the gas inside the container is directly proportional to the number of moles of the gas inside the container. This is the thing everybody should learn. So I'm closing this session with this. Hope you all understood this session. I was just